Hello, hello. This is the notes for graphing quadratics and their features. So as you guys might remember, quadratics are anything that has x squared as the leading term. And they are going to create this U shape, right? So it could be opens up like this or opens down like this. So that will be the first thing that we talk about. So in colloquial terms, colloquial means like common things, like things that we would just say up, right? So we might say like it opens up like a maybe like a smiley face, right? Or it could be like opens down like a frown. So we would say opens up or down. And that means that we have like this up direction or the down direction. And the mathematical way that we would say that is we would say concave up or concave down. Right, so we can say either of those things. This one that's on the screen here is concave up because it's like up like a cup. That's kind of what I remember. It's up like a cup, like you could fill it with water and it would hold water. Right? If it's facing down, it's like down like a frown, like sad face. So that's the first part. Then you might say, okay, there are some important points here. So we're going to talk about the important points that are on this graph. And I'll start by talking about the orange dots here. The orange dots are where it touches the x-axis. So where the graph touches the x-axis. And there are a few names for these, a few names. The biggest one is solutions. These are the solutions to our graph, right? Solutions to our graph. They're also known as x-intercepts because it's literally where it intercepts the x-axis. They're also called roots. And there's another one that's eluding me at this time. There's another name, I'll come back to it. So those are our orange ones. I'm going to call them solutions for today because we are going to learn to solve these by graphing. And so there'll be solutions in our answer. So we have our solutions. We also have that sort of like teal dot, right? This teal dot here. And that is where the graph touches the x-axis. I'm sorry, the y-axis. Because remember, that's the up and down axis there, right? The y-axis, and of course you guys know that's called the y-intercept. So I'd say this is the y-intercept. So where it touches the y-axis. And then finally, we have our green dot there, right? Our green dot here. And that green dot is the lowest point, right? The lowest point. And since it's the lowest point, it can be called, it is the vertex, right? It's where the graph like stops going down and starts going up again. That's called the vertex. And since it's the lowest point, it's called the minimum. Right? It's the lowest point on our graph. It's the minimum point on our graph. So I'm going to go ahead and say it's like where it turns. Sometimes that's what we say. Where it turns, a turning point. We call that the vertex. And since it's the lowest point, it's called the minimum. Do you have any idea what it would be if it was the highest point? What's the opposite of a minimum? It'd be the maximum. So the highest point is the maximum. Right, so that would be like if our graph looked like this, that would be this point up here. That'd be the max. It's still the vertex because it's still the place where it's like going up and then coming down again. It's still the turning point. But this time it would be a maximum instead of a minimum. It's the highest point on our graph. So these are some things that we can use. They're called key features, things that we can use in order to talk about the graph. So we can talk about it using its solutions. We can talk about it using the y-intercept. We can talk about the vertex, which might be a minimum or it might be a maximum. Okay, so that's how we can sort of talk about it. And then there's sort of this other thing that we can do, which is called solving by graphing, right? So as you guys know, we are often trying to solve equations. When we have a quadratic, to solve a quadratic means to find the x-intercepts. right? We want to know where it touches the x-axis. All right. So if we want to know where it touches the x-axis, we might have a few different situations. We might have a situation where it looks like this, right? We could say, okay, well, we have a point here, and we have a point there. So this has two solutions, right? We could say like, oh, maybe it's -3 and +1. I don't know. We'll see what those numbers are. So we have that solution. We have that possibility. And then we also have the possibility where it just comes down and touches and then goes back up, right? So we might have just one solution here. In both of these situations, they could be concave down. So it could be like this. This would have two solutions like that. Or it could be like this. It could have one solution like that. Okay, so it doesn't matter which direction. I'm just doing concave up for right now. And then we also have the possibility that it does not touch the x-axis, right? So you can imagine if I have a graph that goes like this, right? There's no solution there, right? So this would be called no solution or zero solutions, right? It could also be down here. Notice though, one thing that does sometimes like trick us up is if it's like this, that actually does have solutions, because if these arrows means goes on, right? So since it goes on, it's actually going to have two solutions there, right? So just because it's not touching on the way that they drew it doesn't mean that it's no solution. It actually has to have no solution, like it's never going to touch. So in order to be concave down, it would have to be underneath the x-axis like that. Okay. So if we don't know what the points are exactly, we're going to use a tool. We can use a graphing tool. In the classroom, we would use the graphing calculator. We can also use Desmos since we're online. So we're going to go ahead and solve this equation, right, by graphing. We want to know what the x values are, right? So what we're going to do is first things first, make one side equal to 0. So we have 2x squared plus 3x equals 4. I see that the x squared is positive on the left side, so I'm just going to move everything from the right side over. So I'm going to go ahead and subtract 4. There's no like terms here, so I'm going to pop it on the end there. So 2x squared plus 3x minus 4 equals 4 minus 4 is 0. So first step is to make one side equal to 0. And then the second step is to type the equation into Desmos. So I'm going to go ahead and open up my Desmos app here. There we go. So I have 2x squared plus or minus, I don't remember, I'm gonna click back, plus 3x minus 4. So I can see that parabola shape, right? I can see that I have my vertex, my y-intercept, my x-intercepts here. But remember that I only care for solutions. I only care about my x-intercepts. So I'm gonna turn off these guys. And those are my two solutions. I see that it has two solutions. So the solution would be -2.351. So I'm going to write here, x equals -2.351. And x equals, go back to my graph. I also have 0.851, right? 0.851. So I'm going to go back 0.851. So those would be my two solutions for this. All right, you guys can rock it out. Let me know if you have any questions. I will talk to you soon.